class. Today we are going to talk about our third and final method for solving a system of equations. So we've talked about solving a system by graphing and substitution. And now today we're going to use the method elimination. This is actually the one that most people tend to like the most. I don't really know why, but it is. So I anticipate that you guys are going to pick up on this really, really quickly. So remember that anytime I'm solving a system, my solution or the answer is a point. So we always have to be writing our answer in the form x comma y, where we have numbers. And we said the graphing is really easy when we're in y equals mx plus b form. Substitution is handy when we have an x equals equation or a y equals equation, because then I can take one piece and plug it in for that isolated variable. Elimination tends to be our favorite, usually because we can do it in almost every situation. We don't have to have our original problem to look like a certain form in order to do elimination. Let me show you what I mean. If I give you a system that looks like this, 3x plus 2y equals 4, and I give you 3x minus 2y equals -4. And I said, hey, let's solve this system. If we were going to graph these two lines, we would have to put it into y equals mx plus b form. So we'd have to solve for y. And that's kind of some work. So we would have to do the same thing if we were going to use substitution. For substitution, we'd have to get it into an x equals or y equals equation. And that would take some work for solving for one of my variables. So elimination is excellent because when we do elimination, we work our problem up and down. So with elimination, work the problem vertically. Well, what do I mean by that? I mean, stack your problem so that the x's are lined up and the y's are lined up. The equal sign is lined up, which will then leave your number on the other side of the equation lined up. So match them up that way. Then once you're all lined up, then you're going to draw a line underneath your problem and you're going to combine these terms. When I say combine, what I mean is if I have a 3x and another 3x, how many x's do I have? 6x. If I have 2y and -2y, my y's end up canceling. My equal sign is going to come down right in the same place. And then we're going to combine our 4 and -4. Well, 4 and -4 equals 0. So when I work my problem vertically, what I want to have happen is one variable to cancel. Which is what happens here. The y's cancel. Now, in order for a variable to cancel, the coefficients, so remember the number in front of the variable, they need to be the same number, but with the opposite signs. So a positive 2y and a negative 2y, a positive 10y and a negative 10y, a negative 12y and a positive 12y. They just have to have the same number but opposite signs, one positive and one negative. And then when those cancel, we're left with this equation down here, 6x equals 0. And I can solve that one like normal, where I'm taking 6 times my x, so I'm going to divide by the 6 in order to get x by itself. So x equals 0. So this is part of my answer. Remember how my answer to a system is always a point. And so the 0 is going to go in the x spot of my coordinate point. Now, once we solve for one of the variables, just like last time, we have to go up and substitute it somewhere. When we're substituting, we can go into either one of the original equations. So you see how I erased my cancel line because I have to go back to the original. And it doesn't matter which one I go into, you can pick. So just for ease, I'm going to go ahead and pick the top equation. So my original equation was 3x plus 2y equals 4. And I'm going to take this 0 that I found as part of my solution, and I'm going to plug it in for the x in this equation. So it's going to go here. And we're going to say 3 times the 0. So the x comes out, the 0 goes in, and the rest of my equation is going to stay the same. Then I can solve for y. So 3 times 0 is 0 plus 2y equals 4. Well, I don't really need that 0 at the beginning, so I'm just going to write 2y equals 4, and then I'll divide by 2 to get the y all by itself. So y equals 2. This 2 I'm going to put back up into my answer that is my coordinate point, and I'm going to circle it. So this is the solution. Again, remember, if I were to graph both of these equations, they should cross at the point 0, 2. That's what's happening. But see, this is all nice and well and good because my y's were already set up to cancel. They already had the same coefficient with the opposite sign. But what happens if I have a problem that's not set up like that? What if I give you x minus 3y equals 24, and I am also giving you for my other equation 3x plus y equals 12. Again, I'm looking up and down. I'm trying to figure out which of my variables, the x or the y, has the same number but opposite signs, and neither of them do. So when nothing has the same number in front of the variable, I can multiply by something in order to make one of the equations have the same number. So we're going to multiply one equation. Okay, so if I'm going to look at my x's, do my x's have the same number in front? No. Do they have the opposite signs? No. Okay, well, let's move on to the y's. Do the y's have the same number in front? No. Do they have opposite signs? Yes. So because the y's already have opposite signs, I'm going to multiply by the y's. We're going to try and cancel out the y's. Okay, well, here's what I do. I figure out what is the number in front of this y when I don't see something. It's a 1. So what can I multiply a 1 by in order to turn it into a 3? I'm going to multiply it by 3. And so what that means is that I'm going to multiply the entire equation by a 3. So we have to distribute this 3 to all parts of the equation on both sides of the equal sign. This is going to turn it into a 9x plus 1 times 3 is 3y, and 12 times 3 is 36. This is my new equation. By the way, This equation is the same as the original equation. I haven't changed it. I just changed the numbers so that the numbers look different, but they're actually still equivalent equations. So now I'm going to use this pink equation and I'm going to copy my original one from the top that I didn't multiply. I'm going to write that one underneath the one that the pink one that I came up with. And now we're going to work our problem vertically. So if I have 9x and I'm combining it with another x, this is a 1x. So this is going to give me a total of 10 x's. My 3y and negative 3y cancel. And now I'm set equal to 36 and 24 gives me 60. Now I'm going to go ahead and smush this equals 60 right over here. I know that my equal signs are no longer in line together, but at least this makes it a little easier to deal with in terms of solving. So now in order to get x by itself, I'm going to divide by 10. X equals 6. Once I have my x, the other thing I need to do is find the y. So I'm going to go back to one of my original equations, either of the black colored ones. So I'm going to go to the top or the bottom. It doesn't matter. So just because the top one's cleaned up a little bit, I'm going to pick that one. So if I have x minus 3y equals 24, so that's my original. Now I'm going to take this 6 and I'm going to plug it in for the x. So 6 minus 3y equals 24. And solve for y. Subtract the 6. And then divide by negative 3. So y equals negative 6. Now, this is not my answer. I cannot leave it just like that because my answer to a system is always a point. So I need to write it in the form of my x comma y. This is my answer. Well, now there's one more way that these problems can get a little bit trickier. And lucky for you, yeah, here we go. Um, Here we go. Another way that I can see a problem. Wow, that was funny, wasn't it? How I Okay, if I give you 8x minus 5y equals 11 and 4x minus 3y equals 5. Okay, again, I'm going to solve by elimination. And so when I'm using elimination, I'm going to try and get the same number, but opposite sign for one of the variables. So I first got to pick the variable to eliminate. So when I look at my original equation, I'm going to look first at the x's. Do my x's have the same number in front? No. Do they have opposite signs? No. Okay, so then we'll move on to the next one. Does my y have the same number in front of it? No. Does it have opposite signs? No, this time they're both negatives. Okay, well, that means that I've got to ask one more question. When neither of these two things is happening, then I ask myself, if I'm looking at my x's, can I easily take my smaller number, so the smaller coefficient, multiply it by something to get to the bigger coefficient? So can I multiply 4 by something to get to 8? Yes. Okay. Well, let's check with the other one though, just to be sure. Can I take my smaller coefficient for y, so the -3? Can I easily multiply a -3 by something to get to a 5? No, 5 is not a multiple of 3. So that tells me that I do not necessarily want to work with the y's. So we are going to eliminate x. So what that means is that I'm going to multiply my smaller coefficient. Okay, so the smaller coefficient was 4. So I'm going to ask myself, what can I multiply 4 by in order to change it to an 8? I can multiply it by 2. But right now they have the same signs. They are both positive, and I need them to be opposite signs. So when they're already the same sign, we are going to actually multiply by a negative number. And so doing that, we'll take a -2 times a positive 4x and change it to a negative 8x. A -2 times a negative 3y is going to give me positive 6y. So you see we are distributing this -2, but we have to do it to the other side of the equal sign as well. So -2 times 5 is -10. So what we've done is we've changed up the second equation so that when I use this green equation and the original one from the top that we didn't multiply by, so 8x minus 5y equals 11. Now my negative 8x and my positive 8x will cancel because they're giving me 0 x's. And I'm combining vertically for my y's. 6y minus 5y gives me just 1y. And a -10 and a positive 11 gives me 1. So now in my answer, 1 is going to go in the spot for the y. And I just need to find the x. So in order to find the x, I'm going to take this 1 and I'm going to plug it back into one of the original equations at the top. Again, it doesn't matter which one. I'm going to go for the top one just because right now it's already cleaned up. There's no multiplying that's happening to it, but you could absolutely do the bottom one if you wanted instead. So I'm going to take this 1 and substitute it in for the y. So the y is going to come out and a 1 is going to go in its place. Notice how I'm putting parentheses around the number that I'm substituting in. You guys will see me do that every single time. So I have 8x minus 5 times 1 is 5 equals 11, and we solve for x. So first, we're going to add the 5 over. And then we're going to undo this multiply by 8 and divide by 8. So x equals 2. Now we write our answer in the coordinate point. So the 2 is going to go up here in the x, and we are done. Okay, in class, we are going to do more practice with substitution and elimination. So we are going to practice this because I've only given you 3 examples. That's not that many when it comes to these kinds of problems. But we've been talking here for about 21 minutes. So you guys are done. Have a great day, and I will see you in class next time. Bye.